Hello guys, how are you today? I hope you are doing well. Today we will see how to make histograms and bar charts. As usual, I will give you a bonus by showing you how to make pie chart on ggplot2. Before any transition to practice, the question must be asked: what is a bar chart? What is a histogram? According to Wikipedia, many sources consider that this diagram has their origin in the work of William Perfet, followed by Carl Pearson. So what is a bar plot? A bar plot or a bar chart is a graph that shows each level of a categorical variable by rectangular bars with height or length proportional to the value they represent. Bar can be drawn vertically or horizontally. Bar chart shows comparison between discrete categories. One axis of the diagram shows specific category being compared, and the other axis represents the measure value or the frequency. Some bar graphs represent group value and thus combine two categorical variables. Such a graph can also be used for a grouped continuous variable. What is a histogram? A histogram is a graphical representation used to present the distribution of a continuous variable by representing it with columns. Histograms are similar to bar graph, except that histogram group observation of the continuous variable into intervals. The width of the interval defines the corresponding beam width, and the height is proportional to the frequency of the interval considered. By default, R automatically produces histograms of the same width. The primary purpose of such a graph is to analyze the distribution of the variable studied. Here is some example. As you can see on the left side, you have a bar graph showing discrete values. Between each bar, you have gaps. On histogram, we don't have gaps. So, before starting, I have to thank Hadley Wickham for his ingenuity. You can see his reference manual about data visualization on air on the internet. So the title is Elegant Graphic for Data Analysis. For practice, you have to use two packages. First is the package OpenXLS to import our dataset. The second one is Tidyverse. The package Tidyverse contains 7 packages. It contains also the package ggplot2. So we don't need to load the package ggplot2. After loading the package Tidyverse, we define the directory to save our information or our graphic if we need. Inside this directory, we will import our data. So the data to import is the previous dataset. In this dataset, we will exclude China, since China has the most famous manufacturing value added in 2015. So since we need to present each region clearly, you have to remove these countries. Now we will present you a command that will help you to have information about aesthetic parameter. So we use this command, vignette of ggplot2 spec. It will give help about aesthetic parameter, as you can see, color, field, and so forth. Now here we will show you how to plot histograms. Now for a simple histogram, we specify the data set and then the variable we want to plot. We can color each histogram and then change the filling color. Now let's look at how we can add a vertical line showing the mean for each region. So to do so, we have to summarize our data. This operator, after looking this database, it will group it by region, and after grouping, it will summarize the manufacturing value by mean. So you have this set of code. Next grouping, next summarizing by mean. As you can see, you have the mean for each region. Now let's plot the vertical line. To plot a vertical line on a histogram, you have to add geom v-line layer. So the data considered here is small, as we have computed, and then we add an intercept considering each mean, and we color by region. The line type is dashed. As you can see in this plot, we have removed legends. Now we can change the position parameter. To change the position parameter, since we have bar color by region, we can put each bar near the other one by region. To do this, you use the position dodge parameter. So you have this graph. We can also add a density to the plot. To add the density to the plot, you have to specify the vertical axis to be not a count but a density value. So y-axis is the density value, and then we add a layer corresponding to density alpha equal to 0.2 to modify the transparency. You have this graph. Since this graph does not show clearly the span of the density, we will sample a normal data set of 500 observations with mean 0 and standard deviation of 5. So we transform it as a data frame to plot. You can use this code to do it. Now we plot a stigmatic density on a histogram. So you have this code. As you can see, you have modified the transparency filled by red and color in green. We can also modify the kind of color for the bar. So we can specify the gray color by level and specify the alpha, which is transparency of the bar. By doing so, we have this graph. Now let's see how we can modify also the adjustment of the density around the bar. We can modify it by specifying adjust. We have specified the line type to be dashed. We can also specify the beam parameter, which will modify the width of each bar. So to do it, we use beam on the histogram layer. We have this graph. As you can see, we have a symmetric graphic. We have added a vertical line corresponding to 13.3, as you can see, and color in red. Now let's move to another sequence. Here we can plot a frequency curve on the histogram. To plot such a graph, we have to use the layer geometry poly. So geometry poly will show this graph. The frequency poly can also take the beam parameter. So the frequency curve passes on the top middle of each bar. Now let's move to bar plot or bar chart. A simple bar chart can be concerning the frequency of each region. So to do such a graph, we have this code. Each region counting the number of observations by region. Now we can plot the manufacturing value added by region and color by region with this code. So as you can see, this graph summarizes the manufacturing value added by region. So it sums the value for each region. To verify it, we can use the tapply function. As you can see, the summary here is 412, as you can see up there. Here, to plot a continuous variable with a categorical one, we use the geom call instead of the geom bar command. Now we can fill each bar by income. So to do it, we have this graph. Now we can personalize or modify color not to be the default colors. To do it, we specify the layer scale fill manual. So with scale fill manual, we precise color we want, and then we have this graph. We can also rotate this graph to have bar horizontally. To do it, use the layer curve flip. So with curve flip, we have this graph. We can also precise the color to be filled gradually. You use the command or the layer scale fill brewer. In this case, I've used the color red. So you see the red color gradually. We can also use the decreasing darkness. So we use the direction equal to -1. As you can see, the darkness will be decreasing. We have added also the jump point layer to plot the point on each bar, the point corresponding to each country by region, as you can see there. So position start is to start the point on the bar, and then the parameter of the start position, as you can see there, we modify the position. We can modify it to see the way it changes. Now we can plot and fill by income, and then dodge each bar near the other corresponding to income. As you can see, we have this kind of plot. So after upper income, we have low middle income, and then we have low income, as you can see there. Now we will see how to plot confidence interval on a bar chart. Here we write a command that computes instead of sample standard deviation the whole population standard deviation, to avoid the problem of having a missing standard deviation by group of one observation, since the default standard deviation computation used n-1. So you have this command. We will summarize our data to have mean, standard deviation, and number of observations. As we have presented the next thing command, we use it to select three variables grouped by region and income, and then summarize by mean, standard deviation, and number of observations by group. We transform it after to a data frame, and then we will plot after this. Now we will show you how to plot a confidence interval around the mean. Here, to do it, we have to use the geom error bar layer, as you can see there on the code, geom error bar. We will plot the 95% confidence interval around the mean. So with the assumption of normality, we have this formula. This is the t-value corresponding to the mean, and then we dodge our confidence interval to the bar with position dodge, and we precise the degree. So you have this graph. We could also plot a confidence interval around the mean by showing in which proportion of the standard deviation we are far away from the mean. So to do so, we have, for example, 0.4 standard deviation. We have this confidence interval. Now, how can we do to add a label to a plot? To add a label to a plot, we use the layer geom text. So you have geom text, you precise what is the label and any other adjustment parameter. Here you have the label, which is the rounded value of the mean at 2 decimals. So you have this graph. Now, how to label with a shape around the text? So we want a shape around this text. To do so, we use geom label. So geom label, we precise coordinate, and then we precise the label. So you have this graph. Here we will show you how you can make a pie chart on ggplot2. So to do such a graph, you have to compute your data corresponding stick to the pie chart you want to do and then follow the step I will show you. So here we summarize our data. We first read the data. So after reading, we will group it by region. After grouping by region, we will summarize each region by sum. So for each region, we sum the manufacturing value added, and then we use the mutated function to compute the proportion of each region in the manufacturing value added of all our samples. So as you can see down there, we can print such a data set. You have the proportion of each region, and then you have the manufacturing value added corresponding to the sum. Now we can plot a bar chart, so you have such a graph. Now for the next step, we can add a text to this graph. To do so, you have to use geom label as you have shown up there. Here we have added the percentage symbol. Now after adding the text, you have to change the form of the graph. To do so, we will use the polar coordinate. So we use the layer geom called polar. So you have to precise that it is the y-axis we want to show as a cycle. So you complete the pie chart with this code, and then you have this graph. Now as you can see this pie chart, we have a line around the pie chart. You have a text label on the y-axis, and we have a line thickness on the axis. So you have to remove all this to show a pretty pie chart inside of this one. So we can remove the axis line with this code. After removing axis line, we will remove the axis text with this code. Thereafter, we remove the line thickness. So we remove the line thickness with this code. We could do the same pie chart with only one code. We have just to add each part of the previous code on the same ggplot element. So we have bar plus geom label plus code polar plus temp classic to change the temp plus any temp parameter we have used to remove component of the graph. So you have this same graph. Okay, I hope this video has helped you to understand the way you can plot a bar chart and a pie chart. So if this has been useful to you, you can share with your friends, like and subscribe to my channel to have another videos of innovative tools to use with data. Have a nice day.